We are discussing equivalent weight, which is really very important, especially for KHC2O4, because in the different condition you will find the different kind of equivalent weight for the KHC2O4. Very first we have to understand that how we find the equivalent weight, and you write here the equivalent weight is equal to there the molecular mass divided by there the n factor, right? So n factor is calculated in the different conditions in the different manner. Although one thing be clear, n factor is the number of moles of electrons lost or gained per mole of the substance. Sometimes you find it as a total positive charge, sometimes in the salt especially, sometimes as a replaceable hydrogens, sometimes replaceable hydroxyl ions HO minus, and all that. In the different condition we take different ways to find the n factor. Here we take the different cases of the KHC2O4. KHC2O4, understand this that this is basically in general acting as a salt. You write here that K plus in HC2O4 minus, this is acting as a salt, and so for this one equivalent weight is equal to there that M divided by 1. What is this one? One is the total positive charge here, right? Total positive charge. Where is this total positive charge? This total positive charge is there with this K plus, and this only is the n factor for this one. And one thing very interesting I would like to tell you that here you take this one is by default. By default means if nothing is given, then we take this as a salt and we find its equivalent weight like this. What else? Else is we can see that KHC2O4 is also acting as acidic salt. Acidic salt acting as acid. So if we have this kind of reaction where it reacts further with the base like KOH, that will be giving here the K2C2O4 and H2O. In this condition K2C2O4 forms. Here one of the hydrogen, this is acting as AC, and one of the hydrogen is lost. So that's why in this case we write here the equivalent weight is equal to M by 1. What is this one this time? This time this one is again there the number of replaceable hydrogens. Replaceable hydrogens, and that is 1 because here it is 1, right? So although coincidentally we are getting 1, but the approach is different, and certainly we must be careful for this one, right? So now let us move to the third condition when KHC2O4 is acting very interesting as a reducing agent. Let's take here one reaction of KHC2O4 with some of the oxidizing agent, like I take KHC2O4 reacting with MnO4 minus, and that gives CO2 plus Mn2 plus. Now you think in this case what happens? In this case you will observe that this KHC2O4 here the C is oxidized to CO2. Here the oxidation state is plus 3, and here the oxidation state is plus 4. This is oxidized. Here this one MnO4 minus is acting as oxidizing agent, and this one is now acting as reducing agent where oxidation takes place. This is acting as a reducing agent undergoing oxidation, so the loss of electrons, but per mole of KHC2O4 how many mole of electrons are lost? So there per atom the loss is 1, right, into, in 1 mole of this KHC2O4 how many carbon atoms are there? 2 into 2 is equal to 2, right? So here the equivalent weight, right, equivalent weight is equal to m by 2. What is the 2? 2 is the n factor, total number of moles of electrons lost per mole of KHC2O4. So in this case you find different equivalent weight, and we have to be careful regarding this. Thank you.